Hello, I'm Dean Whiting from Pathology Technology Australia. Back on April 27th, we released the COVIDeocast number 5, which dealt with the antibodies to COVID-19, the so-called serology tests. And in a moment, we'll go into edited highlights of that video, which talk about the fundamentals of the antigens, the antibodies, and the so-called serology studies. But in the meantime, this is a rapidly changing field with developers and producers coming up with even better tests for the antibodies, which reduce the false positive and the false negative rate down substantially. This offers us an opportunity to do some testing which makes sense in a low prevalence environment like Australia. Unlike the US, where the prevalence is very high, antibody testing has been used to demonstrate that the background level of infection is possibly twice the level that has been detected by the PCR assays. So in the US, where you have a high prevalence, it looks like the number of people infected is much, much higher, maybe double what the initial screening suggests. In Australia, our prevalence is really quite low. And with a low prevalence disease, you need very highly specific and sensitive assays which give you very few false positives and false negatives. And that way you can make some meaningful determinations about the progress of the disease, the build-up of immunity, and how people develop antibodies to the COVID-19. So here's the basics again. And I look forward to coming back in not too distant future with a few more recommendations about how we could be integrating the serology tests with the PCR detection tests for COVID-19. So in the meantime, I hope you find this COVIDeocast, I hope you find it informative. Bye for now. But today I'd like to talk in more general terms what the antibodies are. And I'd like to talk about antibodies and antigens related to COVID-19 testing. So you will have heard maybe the term immunoglobulin, you'll see that antibodies are often referred to as IgA, IgG, IgM. The Ig is the immunoglobulin, and that's the basic protein which the human body immune system produces against aggressors in the body. So toxins, foreign bodies, foreign entities, and bacteria and viruses, the same. So as a foreign entity, we'll use the SARS-CoV-2 virus as an example. As they enter the body, they end up producing what's called an antigen. So it's a protein which is specific to that virus. And that protein becomes what's called the antigen. And the antigen is what stimulates the production of antibodies. Now, in the first place, in the nose and throat, the antibody that causes the most rapid and quite maybe violent response is the IgA. So these are the antibodies that cause you to sneeze and cough and suddenly expel what's been taken into the nose and mouth. These are somewhat non-specific antibodies. They're quite short-lived, and so while you can measure them in blood, they're not very specific and can't tell you so much about your infection. You can measure the IgM, which is the next immunoglobulin to be stimulated by the body. So the IgM is quite specific to the invasion. So in this case, it's quite specific to the antigen being produced by the virus. And this antibody rises, becomes quite easily measured after between 5 and 10 days of the infection. And but that rises, and then as the infection is fought, it also falls away. So after the infection is dealt with, we can't measure IgM in the blood anymore. The next immunoglobulin to rise is the IgG. And the IgG is the immunoglobulin which confers longer term immunity. So we often term this seroconversion. So we convert to being immune to a particular entity. So we can measure the IgG for COVID-19. It rises at some stage, maybe between 10 and 12 days subsequent to the infection, but then persists for quite some time. With COVID, we don't know how long that the IgG will persist. In infections such as measles, for example, IgG will be measurable in the blood usually for the individual's lifetime after an infection. But in the case of COVID, we're going to have to wait and see. We can't roll this forward in an accelerated experiment. We have to wait and see what happens here. And so it's important to start measuring these from day one to be able to see how long the IgG persists in the body and what kind of immunity it confers. We'll also be able to measure the antigen. And in fact, the classic way of diagnosing and managing infections like HIV, hepatitis B, hepatitis C, is to measure the viral component, so the viral RNA and the antigen together, because between the two of them, they provide far greater diagnostic accuracy than each by themselves. So we are probably only months away now from being able to measure the antigen as well as the antibodies. And so that will give us the ability to be able to provide the same kind of testing that we would for hepatitis or HIV. And that is that we would take the viral swabs and measure for the viral RNA. And at the same time, we would take a blood draw and measure the antigens and antibodies related to that infection. And that gives us the most comprehensive picture of the current status and also the likely future immunity. It confers another important advantage. We then start to build up a baseline and a picture of what the disease entity looks like in the population. So we can start to see how many people are developing and acquiring immunity. We can start to track that immunity and see how long it lasts. Do we have a lifelong immunity to COVID-19, or will this be short term and we'll have to rely on other methods of managing? So antibodies, antigens, are going to be an important part of the fight, and they will be an ongoing part of how we manage this particular pandemic. And in conjunction with the measurement of the RNA, we will then provide a way to recover from COVID-19 disease. So I hope this has been helpful. I'm Dean Whiting from Pathology Technology Australia.